Hello team, so today we're going to be looking at the non-calculator section of this practice test. Okay, as most of us already know, number one is something that we've already done, but for review purpose, we're going to work on it again, okay? So m squared minus 25, when we see that, usually we have to think of a plus b or a minus b in that type of combination, right? So just remember that when there is no middle term, we'll be looking at the form a plus b times a minus b. What this means is this. You're going to expand it. You're going to do that, and that, and that, right? We're going to expand it out to get a square, right? A times a is a square, and then minus a plus a times minus b, which is negative ab, right? And b times a is plus ab. And then b times negative b is negative b squared. We simplify and we'll get a squared. Cancel out the middle term because it's a negative and a positive. And we have negative b squared. So this is how we know that we have this form a squared minus b squared, right? 25 is 5 squared, right? 5 squared. So to write it out in this form, a plus b times a minus b, we'll have m plus 5 times m minus 5, which is option C. All right, for number 2, select an expression that is equivalent to radical 3 to the 8th. Remember, if there's nothing written in front of our radical, we assume it's a 2. So in this scenario, all we have to do is to divide 8 by 2, right? So we'll have 3 to the 8 divided by 2, which is 3 to the 4th power, which is also option C. All right, number 3 is slightly trickier. Before we fill in any option, I like to just solve it. So let's do this one first. Number 1. So number 1, we have 5 divided by 20x equals 1 over 4x. We cross multiply this and then this, right? All right, so what we'll have then is 20x times 1, which is 20x, equal to 4x times 5, which is also 20x. Because we have the same equation on both ends, we know that any x will give us the same answer, right? Because if we plug in x equals to 1, right, we have to plug in here and here, we'll get the answer that's same. So in this scenario, any x that is a real number will give us the same answer, right? So in this scenario, we have infinitely many real solutions because the two equations on both ends are the same. So any x that we substitute in will result in the same answer. So that's how we do number 1. Let's look at number 2. Number 2, 3x equals 4 plus 5x. 3x equals 4 plus 5x. I want to subtract 3x on both ends, and we'll get 0 equals 4 plus 2x. And then after that, I want to subtract 4 on both ends. We want to have the 2x on its own. So we have negative 4 equals 2x. And last step is to divided by 2 on both sides. So divided by 2 will end with the result x equals negative 2. So that's just one solution. So we know that there is one real solution when x equals negative 2. If you want to check, you can plug this number back into here, right? To plug it back, we have, I'm just going to write it right here, right? 3 times negative 2 equals 4 plus 5 times negative 2. We'll get 3 times negative 2 is negative 6 equals 4 plus 5 times negative 2, which is negative 10. So plus minus 10 is just minus 10. And sure enough, we get negative 6 equals negative 6. So we know that the solution is correct. Last one, this one is the trickiest one out of the three. We're going to try it out, okay? Number 3, we have square root of 2x, radical of 2x plus 3 plus 6 equals 0. We want the radical to be on its own, so we subtract 6 on both ends, and we'll get radical 2x plus 3 equals negative 6. This cancels out, right? And then 0 minus 6 is negative 6. And to get rid of the radical sign, we want to square both sides, right? You want to square both sides, and we'll get 2x plus 3 equals negative 6 times negative 6 is just 36, right? 2x plus 3, so we want to subtract 3 on both sides, so we have 2x on its own. 2x equals 33. Last step is to divide both sides by 2, so we'll write add x equals 33 divided by 2. Okay, what I mean it's tricky because we're going to see this not matching up when we plug it back in. All right, I'm going to erase number 1 and number 2. Erase number 1 and number 2. And I'm going to try and see what I mean. So this is what we have for x, right? So let's go ahead and plug it back to our equation. Radical 2x, right? X is in this case 33 divided by 2 plus 3 plus 6 equals 0, right? So 2 times 33 divided by 2, so just cancel out the 2. So under the radical, we have 33 plus 3, which also equals 36. So root 36, we know would be 6, right? 6 times 6 is 36. That's why square root of 36 is just 6, right? So we want to then bring this down, right? 6 plus 6. Okay, so this is the trouble. We get 6 plus 6, which does not equal to 0. So we know that there is no real solution because the solution that we just solved for x does not equate to 0, right? So in this case, we know that it is no real solution. So even though we were able to find and solve for x, it's always good to check if your solution is a real one by plugging it back into the original equation. If it doesn't match up, then it's not a real solution. All right, let's look at number 4. Number 4 it looks kind of tricky, but it's actually very simple. All you have to do is you want to make sure that you combine the like terms, right? So here we have the x squared plus x squared and then minus x squared, right? So let's try to do this part first. So we have 3x squared plus 2x squared minus x squared, right? So 3 plus 2 is 5. 5 minus 1 is 4, right? So we get 4x squared. Okay, let's check out the y's, right? So y's, we have 2y squared plus y squared minus 3y, right? So we have 2 plus 1 equals 3. 3 minus 3 equals 0, so that just cancels out. So we're not going to write anything. The last part is the x, right? The 3x. So we have negative 3x plus negative 2x minus x, right? Always remember that we keep the sign that it follows, right? So in this case, we have negative 3x minus 2x, which is negative 5x, minus x, which is negative 6x. So you can either put in here, you can either put in 4x squared minus 6x, or if you want to do negative 6x plus 4x squared. So either way works. All right, number 5. A student solved 3 over x minus 4 equals x over 7 in 6 steps, as shown. So in this situation, we can just follow what it does, right? Okay, so it's cross multiplying. It wants to move x minus 4 on the other end. So we multiply x minus 4 on both ends, right? So we have 3 over x minus 4 equals x over 7. You want to multiply x minus 4 on both ends to cancel out, so the 3 is completely on its own. So here we arrive at the same step, which is 3 equals x times x minus 4 over 7, right? So first step, so far, so good. Okay, next step. So we see that it multiplies 7 on both ends, right? So we arrive at 7 times 3 equals x times x minus 4 over 7 times 7. So this cancels out. Indeed, we also get 21 equals x times x minus 4. So this step is also correct. So what it does next is it expands the x times x minus 4, right? So here we're going to keep the 21. 21 equals x times x minus 4. So we have x times x, which is x squared. X times negative 4 is just negative 4x. So this step is, again, correct. All right, so the last step, not the last step, step 4, it moves 21 to the right side. So by doing so, what it means is we subtract 21 on both sides. So we minus 21 to arrive at 0 equals x squared minus 4x minus 21. All right, so far so good. Okay, step 5, it might be a little bit trickier, but all you have to do is you have to factorize it, right? So here we see that the options are 7 and 3. And because we have a negative middle term, it means that the multiple of 7 and 3, it has to be the bigger number that's negative, right? So let's just try to expand what they have to see if it's correct. So we have 0 equals x times x minus 7 times x plus 3. Let's cross multiple. We got 0 equals x squared plus 3x minus 7x minus 27. All I did was expand, right? And this, sure enough, is the same as this, which is 0 equals x squared minus 4x minus 21. This matches this, so it's the correct factorization. So from here, we know that we have x minus 7 times x plus 3. Remember, our last step is to flip the sign to find our zeros, right? So we're flipping the sign of this, so negative 7 becomes 7, which is correct. And then positive 3, we're flipping the sign, so it becomes negative 3, right? So, okay, so those steps are correct. The last step that we have to do is to plug back those numbers to see if they're actually correct. So let's try 7 first. So we have 3 over 7 minus 4 equals 7 over 7. And let's see, 7 minus 4 is 3, so we have 3 over 3 equals 7 over 7. Any number divided by itself is 1, so we have 3 divided by 3, which is 1, and 7 divided by 7, which is 1. So we know 7 is a correct solution. The next solution that we want to check is negative 3. All right, I'm going to try a different color so it doesn't look too cramped. Let's try navy. So I'll plug in negative 3 back into this function. We have 3 over negative 3 minus 4 equals negative 3 over 7, right? Negative 3 minus 4 is negative 7. So on the left side, we'll have 3 over negative 7. On the right side, we just have negative 3 over 7. So it is correct because we have negative on both sides. And then 3 over 7, right? So in this case, we know that this person correctly solved all the steps. So the answer will be A. All right. Okay. Number 6 is tricky. We need to recall some terminologies. The first term that we want to recall is what a transversal intersect is, right? So transversal essentially means this. Transversal means that it's a line that passes through two lines at two different points, okay? And the other thing we need to know is the alternate exterior angles. This thing right here, the alternate exterior angles, which is defined right here. An alternate exterior angles are a pair of angles on the outer side of each of those two lines, but on opposite sides of the transversal. So what it looks like is this. So if I have a line, so this is a parallel line I have, right? And I have a line going through. My alternate exterior angles can be found here. I can find it either at A and H, right? We're on the outside and opposite, right? Or I can find it at here, at, let's say, B and G, right? So those are the two alternate exterior angles in a parallel line. So part A is to draw a transversal through the point that supports Ricky's claim, or select none. Right, so let's look at his claim. Ricky claims that angles within each pair are congruent to each other, but not congruent to either angle in the other pair. Right, so this example, we know that, hey, we need to draw a line like this to get our alternate exterior angles, like how I've shown you here. So this is proving his claim. This is supporting his claim. On the other side, on the other end, if we want to refute, which is to disprove his claim, which or going against his claim, we can draw a perpendicular line, because when we have a perpendicular line, our angles will not be congruent, right? We don't have alternate exterior angles, because alternate exterior angles, as you can see, is here and here, right? So when we have a perpendicular line where this is just 90 degree, 90 degree, 90 degree, 90 degree, it does not create alternate exterior angles. This question might seem a little bit tricky. It requires us to refresh our memories of angles and their identities. So if you have questions, you can email me. I can do more in-depth exploration on this topic. Okay, so that's number 6. And let's move on to number 7. Okay, so which inequality represents all possible solutions of -6 and less than -12? All right, let's see what we can divide on both ends. So 12 and 6 are all divisible by 6. So I'm just going to go ahead and do that first. I want to divide it by 6 on both ends. So we get -n less than -2, right? Remember when we flip, if we want to cancel out the negative, and by doing so we multiply a -1. When we have a negative multiplication or division, we have to flip the sign, right? So to get rid of the negative, what we have to do is to flip the sign right here. So we divided by -1. Let's say divided by -1, -1. So what this will then look like would be n, right? N greater than 2, because we divide by a negative number, so we got to flip the sign. So this is what we arrive at. The answer is B. A common mistake would be not flipping the sign and just divide by -6, right? So if you do that, what we'll have is, let me change different color. If we only divided by -6 without flipping the sign, it will be -6n less than -12 divided by -6, we'll get n less than 2, right? Which is an option here. So this is like a tricky option. Just remember, whenever you multiply or divide by a negative number, you have to always flip the sign. So our correct answer is actually B. All right, last question. All right, we had a very long unit on this one, so hopefully you guys recall, okay? So recall that sine right? SOHCAHTOA, SOHCAHTOA, right? SOHCAHTOA. So if we want to find sine, we want it to be sine equals opposite over hypotenuse, right? Hypotenuse, to find the hypotenuse, we know that it's across from the box that is 90 degree, right? Opposite is just opposite from the angle that we're looking at. So it's trying to tell us to look for sine B. So our angle will be at here, right? So opposite of this angle will be here, right? 21. And our hypotenuse can be found by looking for the box and whatever side that's opposite from the box, or if you don't really want to look for the box, hypotenuse is the longest side. So we have all the sides given of 20, 21, 29. 29 being the longest side would then be our hypotenuse, right? So sine B, in this case, sine B will be opposite, which is 21, over hypotenuse, which is 29. We can't simplify this further, so all you have to type in is 21 over 29. 21 over 29. And that's how you do this question. Please let us know if you have any further questions that we can help clarify.